Good afternoon, TPC. This is part of a much longer presentation than I normally give. My name is Allan. I am the lead admin, I guess you'd say, for the Project Sane. Anybody here ever scan anything on a Linux platform or a BSD? You were using my code, yeah. Not only mine, though. There's a whole army of devs that are working on various bits of this ecosystem. Let's talk a little bit about it. So it's a scanner driver suite for Unix and Unix-like systems. It actually runs on OS2 and a bunch of other weird stuff too. Unlike Twain, it separates into two pieces. There's a UI front-end component, and then there's what we call backends, which are the drivers, and there's no UI embedded in the drivers, unlike Twain. So that makes it possible to write a very small number of front ends and a very large number of backends, and sort of separates that. There are 87 separate backends supporting it's about 1,500 scanners now. It's 500,000 lines of C, and it is under an unusual license, which is the GPL plus an exception. And that happened because of how old the project is. And at the time the project was started, we were seeing things like Star Office and those kind of products that were closed or semi-closed source, and we were expecting to have to link against those kind of products. There was this sort of halcyon era in the mid-90s where we thought Linux was going to become the OS, but the the applications that we were running were all going to be closed source, and so we were going to need to talk to closed source apps. So we have an exception in our license that allows linking a GPL library against a closed source application, and the text of that exception is horribly written and is a case in point as to why devs should never pretend that they're lawyers. And it's part of the reason that the LGPL actually exists, is the same license, because it's bad, and we can't do anything about it now. How did all those drivers come about? Well, the best case scenario would be, hey, you get driver documentation from the manufacturer of the scanner, and you write the code and you're done. Or they write it and they give us the code, and that happens occasionally. But almost never do those two things occur. And so we are forced to reverse engineer. You got four choices here. And the first one, the getting a USB trace or a SCSI trace of the Windows driver in action, is the most likely. And that's the one I usually use. And here's the workflow for that. You make multiple scans, changing one setting in the Windows driver between each scan, and with a sniffer installed in the Windows driver model stack. The Windows driver model, for all of its failings, has some nice features, and one of that is that you can insert shims at various places. And so we stick a shim in, and we log the traffic as it flies by. Then you extract the logs, you prune it down to the operational data, and then you use something like diff to actually compare the data and see what changes each time you flip some switch in the Windows driver. Of course, I use Perl for all that. Then you write a small program. I actually have a Perl program that takes those and turns it into a C program, source code, that I can then compile and run, and it will send those same packets back to the scanner and see what the scanner does. So it gives me a chance to parrot that data back. And that works fairly well, but you must be sure to keep your hand on the power switch, as it says there, because if you've typoed something or got something wrong, it is certainly possible that you can slam the carriage into the end of the bed and break the scanner. It has been known to happen. So then another thing we do is extract the image data from the logs, and then we sort of take a look at the protocol and say, well, what does this most resemble? And we take one of the existing drivers and we copy it, and then we hack it into shape and make it do the same thing. So I'm going to give you an example. Here's a Canon DRC 225. It's a SCSI over USB machine. End user had this box, had no programming skills, but could take USB snoops. That's what a USB snoop looks like. I wrote a Perl script. That's one packet. That's 4 packets after it's been boiled down, because most of the data was useless. So then that's an important packet. Hey, that's the width and height of the scan, right? So, and this is the image data. This is very much like the Matrix. I've been doing this for 17 years. I no longer see the code. I see blonde and I see brunette. No. So that's what the image data actually looks like when you rip it out of the log, because I just guessed the width and height and I guessed wrong. So I zoom in. Oh, I see something. There's a stair step going down and to the right, black lines across the bottom. So that means our image width was wrong. We adjust the image width. Oh, there's something in there. All right, let's zoom out. Ah, there's something there. All right, so let's go ahead and make the image wider. Yep, there's something right there, but it slants now to in the other direction. That means the image is actually a little bit narrower than we thought it was. So we adjust it. Now it's 9.99 times as wide. Now you got data. But here's something weird. Scanners are like ramens. They do everything in threes. Who knows the reference? And I only see twos here. That means I'm missing a third of the data, right? So that means it's really 1.5 times this wide. So we zoom in, we see that that's really the case. There's two black lines and one white line. That means it's interlaced. So I back out 1.5 times. Now I've got 3 of each. And something else you'll notice. The RGB now look light gray in one of each of the representations. That means that I now have color data and I know which channel is the R channel and which channel is the G channel and which channel is the B channel. So then I write a C program that descrambles that, slaps it together and interlaces it correctly, and now I've got RGB. Now it's upside down and backwards, but I can handle that. I'm a Perl programmer. So that is what it takes. The lessons of this are some types of scanners are easier to support than others, and the big lesson for manufacturers is that lack of documentation will not stop me.